closely. First of all, how can you tell that a function's inverse is also a function? There are some properties that we can pay attention to that will tell us. Given some function f from a to b, the inverse of f is going to be from b to a. If the inverse is also a function, then we can say that the function f is invertible. So, for every f of x equals y in the original function, we will also have an f inverse of y equals x. Remember that the definition of a function is one where each element of the domain maps to one and only one element in the codomain. For an example of a function whose inverse is not a function, we can look at f of x equals x squared. Its inverse is going to be f of x equals plus or minus the square root of x. If we use the vertical line test, we can see that there are some values of x that map to two values of y. For this function, actually, every value of x maps to two values of y. Additionally, not all of the elements in the domain, which is the x-axis, will have mappings to y values, which also makes this an invalid function. So notice that there are no negative x values. With our diagrams, we can visually check the two requirements for a valid function. 1. All elements from the domain map to something, and 2. No elements from the domain point to more than one item in the codomain. To investigate whether a function is invertible, we think of those properties in reverse. If we inverted the domain and codomain and the mappings, would the resulting diagram be a valid function? In the examples below, for the first function, b is not being pointed to, so if we inverted this, b would not have an output. For the second function, again, b is not being pointed to, and c is being pointed to by two items. So if we inverted this, the input c would map to two different outputs, 2 and 3. That would also make it invalid. But for function 3, this would be valid both in its current form and in the inverse. We can further be more explicit about what makes a function invertible by identifying the onto and one-to-one properties. A function is onto if every element in the codomain is an output of something from the domain. So in other words, all elements of the codomain are being pointed to by something from the domain. And a function is one-to-one if nothing in the codomain is the output of two or more inputs from the domain. This means that no element in the codomain is being pointed to by more than one input from the domain. If a function is both onto and one-to-one, then it is invertible, which means the inverse is also a function. If it doesn't have one of these properties, then it is not invertible. For this first function, it is neither onto nor one-to-one, because for onto, everything in the codomain is an output of f, but b is not an output of anything. For one-to-one, it would be nothing in the codomain is an output of two or more inputs, and that's not true for the element c. So this is neither one-to-one nor onto, and it is not invertible. The second function, it is not onto, because b is missing an input. This is also not an invertible function. But the last one, it is both onto and one-to-one, so it is invertible. So to practice, identify whether each of these following functions are onto, and or one-to-one, and or invertible. The first function is both onto and one-to-one, so it is invertible. The second function is neither onto nor one-to-one, so it's not invertible at all. And the third function is one-to-one, but it is not onto, so it is not invertible. Also, let's make sure you can identify these properties if we don't have the diagrams and just the rules. So given that A is the set that contains 1 and 2, B is the set that contains 3 and 4, and C is the set that contains 5, 6, and 7, identify whether each of the following functions are onto, one-to-one, or invertible. So, the first function, f from a to b, with the rule 1 to 3 and 2 to 4. The second function is g from a to c, with the rule 1 to 5 and 2 to 6. And the third function is h from c to b, with the rule 5 to 3, 6 to 3, and 7 to 4. The first function is both onto and one-to-one, so it's invertible. The second function is one-to-one, but it is not onto because the element 7 from the codomain is not being mapped to, so it is not invertible. And the third function is onto, but it is not one-to-one. The element 3 from the codomain is being mapped to by 2 inputs, both 5 and 6, so this is also not invertible. By being able to identify the onto and one-to-one properties of functions, we can identify the invertibility of a function without going through the process of actually finding the inverse. Next time, we will revisit relations and view some properties of relations that we should know as well.